So let's talk about Chapter 6, Costs. This chapter, for many of you, should be a review, but it's a very important foundation for our further study. And what's most important here is the relationship between the average costs. There is the average fixed cost, average variable cost, and the average cost. The average cost is the cost per unit. That's the cost the firms or the producers need to use to calculate their per unit profit, right? The price is per unit, and then you compare that price to per unit cost. If the price is higher than the per unit cost, you're making money per unit. If the price is lower than per unit cost, you're losing money per unit. So the average cost per unit is the most important one. To understand where this average cost, or say average total cost, come from, we need to understand that there are two components in it. Right? One is the average fixed cost, the other is the average variable cost. The fixed cost is just a constant. It doesn't vary with the quantity you're producing. Okay, you produce more, you produce less, it doesn't matter. It is that number. As long as you open your factory, the fixed cost is there. And then if you produce more and more quantity, the fixed cost can be spread over the more quantity that you're producing. So the average fixed cost is decreasing over quantity, right? Higher quantity, lower average fixed cost. The average variable cost, it just depends. It depends on the quantity you're producing, but what we are saying is that it can increase, but at some part it can also decrease. Whether it's increasing or decreasing in terms of quantity produced depends on the marginal cost. There's a relationship between the marginal cost and the average variable cost. Okay, marginal cost and variable cost both depends on the quantity that is produced. Only the fixed cost is independent from the quantity produced. And whether the average variable cost is increasing or decreasing depends on where it is in relationship with the marginal cost. What is the marginal cost? The marginal cost is the cost for the producer to produce another unit. Okay, from one starting point to the next unit, how much it will cost. That's the marginal cost. Sometimes the next unit will cost more. Sometimes the next unit will cost less. Again, if it costs less, right, that actually drives down the average variable cost because the additional unit costs less than the previous unit. Then when you take the average, right, the next one is cheaper, so the whole average is lower. And then if the next unit marginal cost, that marginal cost is higher than the current average variable cost, then that additional more expensive unit will drive up the average cost. Okay, that will make the average variable cost increase. So that's the basic relationship. Okay, we have average fixed cost plus average variable cost equal to average cost. And then you can tell, right, if I have the average cost and I have the average fixed cost, then I can figure out what is the average variable cost. Or I have average cost and I have the average variable cost. Then I can figure out what is the average fixed cost, right? Just AC minus AVC, you'll get AFC. Or AC minus AFC, you will get AVC. So let's look at the short-run cost curves. And we will first look at the picture up here. So this picture is the total cost. Okay, it's the total cost. The green line is the total cost. Where it come from? We have the fixed cost curve, which is the orange line, and we have the variable cost curve, which is the purple line. Right? Because the fixed cost is a constant, right? When I add the fixed cost to the variable cost, I just simply move up the whole purple curve parallelly, right? Move it up to the green line, this total cost curve. That's where the total cost curve C come from. And then let's think about it. This is something neat and interesting, but not essential. So, just listen to it, right? Let's think about the radiant, so-called the radiant, the straight line, right? You start from point 0, the origin, go to point A, right? And if we view it as a radiant, then the slope of it is what? The slope of it, look at the total cost is 216. And then we are producing 80 unit. Right? So the slope of it will be the vertical distance divided by the horizontal distance, which is 27. Okay? And the 27 is here. It's 216 divided by 8. That's the slope. And by definition, it's the quantity divided, it is the total cost divided by the quantity. Right? So that is actually the average cost or the average total cost. That's 27. So what it says is basically, okay, we start from the origin and link to a point on the total cost curve. Then we'll get the slope of that radiant is the average cost. It's the average total cost. If it's the variable cost curve, then the radiant 0b, right? The slope of this radiant will be the average variable cost, which is 120 divided by 6. That is 20. Okay, so in this picture, we can actually sort of see the average cost and the average variable cost. Right? That's the kind of first information. So when you plot the average cost line, still the green line, right? And the average variable cost line, the purple line, you understand it's the slope of all the different radiants coming out of the origin to a point on the total cost curve or the variable cost curve. Okay, it's the many different slopes for many different radiants coming out of the origin onto the total cost curves, and then you plot those slope numbers, you get the average cost curves. So that's kind of where things come from. Help us understand a little bit more, but not really essential. Okay, now let's go back to this picture. Now, if we view 0a as a tangent, right? It's the tangent is the straight line that barely touch just one point on the curve, right? Just touch one point on the curve. And if you have learned calculus, right, you will know the slope of a tangent on a curve is the first order derivative, right? If I differentiate the total cost against the quantity, then I will get the marginal cost. That's basically how we define the marginal cost. So now if I change my view, right, change it from a radiant to a tangent, then the slope of those tangents, there are many different tangents here, okay? The slope of those tangents will be the marginal cost. And notice, because the total cost curve is just this variable cost curve moved up, right? They have the same slope over different quantity, all right? Over the different quantities, they have the same slope. So it's the same marginal cost curve. You have this marginal cost curve. Doesn't matter whether you differentiate the total cost or the variable cost, it gives you the same marginal cost curve. Actually, I will tell you, right, that it's the marginal cost curve really give you the average variable cost. And again, the average total cost, the AC here actually depends on the average variable cost, right? And of course, the average fixed cost. You can see that average fixed cost is lower and lower as you produce more and more quality. So the distance between the green line, the average total cost, and the average variable cost also decrease. That's exactly this orange line. Okay, the orange line is the distance between the green line and the purple line. In other words, as the quantity increase, you will see the average cost line and the average variable cost line, they start to get closer and closer, even though they won't really touch each other, but they will get really close as you produce extremely large quantities. The marginal cost, remember we have this 0A and 0B. You can view both 0A as a tangent and a radiant. So A and B is where the marginal cost, right? This A point A, lowercase a point lowercase b. These 2 points are where the marginal cost curve crosses the average cost curves. Okay, at point B, the marginal cost curve cross average variable cost, and at point A, the marginal cost curve cross the average total cost. So just because they these straight lines, they have dual roles, right? They have kind of dual interpretation. It's both an radiant and a tangent. All right. So this is the relationship between the cost curves. And one last important feature of the cost curve, I have talked about this a moment ago, is that when the marginal cost is lower than the average variable cost curve, it brings down the average cost curve. Okay, just because the additional units are cheaper, it makes the average cheaper. And as I have mentioned as well, if you think about it, the average variable cost really comes from the marginal cost because the variable cost is the one that changes with the quantity, right? So is the marginal cost. The average fixed cost or fixed cost itself doesn't change with the quantity. So it just provides this wedge between the average total cost and the average variable cost. It doesn't really change with the quantity. The fixed cost does not change with the quantity. The average fixed cost just got smaller and smaller, spread out. All right. And then on the other side, right, if the marginal cost is above the average variable cost, it actually drive up the average variable cost because the additional units are more expensive. When you have a more expensive unit put into your stockpile and you calculate the average, obviously it will drive up the average, right? So what it says is actually this point B, lowercase point b, is the minimum point of average variable cost because before point B, marginal cost is lower than the average variable cost, it drives it down. And after point B, marginal cost is higher than the average variable cost, it drives the average variable cost up. So before point B, ABC goes down, after point B, ABC goes up, then B has to be its minimum point. The same story for average cost. The same story for average cost. When the marginal cost is below the average total cost, the average total cost decline. When the marginal cost is above the average cost, the average cost increase. So point A, this lowercase a point, it's also the minimum point for average cost or average total cost. Now finally, because the average fixed cost is decreasing in terms of quantity, even though average variable cost has reached its lowest point, right? It starts to increase. But because average fixed cost is decreasing, the wedge between the average variable cost and average cost is still decreasing. Right? That make the minimum point of average total cost appear at a higher quantity. Okay, or say the reason why point A is to the right of point B is because, yes, ABC has started to increase, right? Supposedly maybe AC will start to right above point B, but it didn't happen. Why is that? It's because the wedge, that is the average fixed cost, is still decreasing, right? This one is increasing, but there's a force that's decreasing, and eventually, right, the increasing force in ABC kind of overcome the decreasing force in average fixed cost that make the average total cost start to increase as well. So the minimum point of average cost is always to the right of the minimum point of average variable cost. Now, I have mentioned that the shape of the average variable cost come from the shape of the marginal cost. So it's actually the marginal cost curve is driving everything. Then where's the shape of the marginal cost curve come from? It come from the so-called production function. Okay, this is a short-run production function. What it says is basically you fix the capital input, but then you keep adding labor inputs into your production process. And supposedly, if you have more labor inputs put into action, you will produce more units. But the so-called marginal productive of labor will decrease eventually. Basically, you cram more and more workers into the same workshop, they will get extremely crowded and nobody can do their work efficiently. So you add 2,000 workers into a, say, 500 square feet workshop, it just everybody probably cannot move. Right? The marginal productivity is extremely low. And then we have this kind of picture, right? For certain input increase, right, the output will increase. And if you increase by another same quantity, the increase in the output will be smaller. And the shape of this production function is so-called the concave shape, right? It comes from the cave, the word cave, right? The outline of the cave is a concave shape. And what it says is exactly if you have more input get into your production process, the additional output will be less than the previous additional output that can be produced. Okay? So let's say, right, I have 100 worker per hour added and I produced 200 units more. And then I add another 100 worker per hour's labor input, and I only got 150, right, produced. So the first 100 in, I got 200 more, but the second 100 in, I only got 150. That's a decreasing marginal output of labor, right? And what it means is increasing marginal cost, right? The per unit labor input output is smaller. So if you want to produce one additional unit of output, right, you need to put more labor into it. And if you assume a fixed wage rate, right, you pay say $20 per hour, but then for each unit of output you need to get more labor into it, then the marginal cost will become higher and higher. So in some early portion, right, like at lower quantity in the production function, you may see actually kind of decreasing marginal cost like this. And that is because it's if you have one worker do everything, it's not very efficient. You get a second worker, the second worker may help a little bit, right? Three workers they may start to just specialize and become very efficient. That's the initial decrease. But then eventually the diminishing return come into action, right? The 1001 worker coming in probably do not do anything just because everybody already have what they have been doing on hand and they are doing pretty well. The additional worker doesn't add anything to the production process. That basically says the marginal cost can be extremely high. So you from this decreasing return to scale production function, right? Early on it's increasing marginal return, but eventually diminishing marginal returns. And then we have the decreasing marginal cost and then the increasing marginal cost. Sometimes in this kind of pictures, you only see the increasing marginal cost, okay? And as I have said, right, the marginal cost curve itself will pass through the minimum point of average variable cost. This average variable cost is really the average of all these marginal costs, okay? The variable cost itself is the summation of all the marginal costs. So this is the average variable cost, and then you put in the average fixed cost in between, or say you add the average fixed cost onto the average variable cost, you will get the average cost curve. So this is the picture you should have in mind. It's become extremely useful. So this is the most important thing to memorize, right? Most important thing to memorize. And there are some calculations later on are also very important, but this picture is what you should memorize. For these average cost curves, we can have many small calculations done. They're basically testing you on the relationship here. The origin is that the simple fact total cost equals the fixed cost plus the variable cost. And then you divide Q, the quantity, on both sides of this equation, you will get the total cost divided by Q, which give you the average cost, equal to the average fixed cost, which is the fixed cost divided by Q, plus the average variable cost, which is the variable cost divided by Q, right? So the simple fact from total cost equal to fixed cost plus variable cost give us average cost equal to average fixed cost plus average variable cost. I hope this is simple enough to memorize. And then from this one, we can have, again, figuring out one another. If you have the average cost and the average variable cost, they will get the average fixed cost. Or if you have the average cost and the average fixed cost, you will get the average variable cost. And the simple fact is, again, rely on this. You can say, if I have the average cost and the output quantity, I will get the total cost. And if I have the average fixed cost and the output quantity, the product of them will give me the fixed cost. If I have the average variable cost and the output quantity, the product of the two will give me the variable cost. Again, if you have every single marginal cost for every unit produced, you sum them up, you will have the variable cost as well. Okay, this is just remind us where the variable cost come from. It's the sum of all the marginal costs to produce each unit. Okay, so I guess the most important thing is here the average cost equal to average fixed cost plus average variable cost. And where the average cost come from is divide the total cost by the quantity, right? Whatever the cost is divided by the quantity, you will get the average cost, and then you can go back to see what is the total cost, what is the fixed cost, what is the variable cost to produce this quantity. Okay. Now let's look at some of these calculation examples. In this total cost function, right, we have 60. It's a constant. This 60 is the total fixed cost, right, or just the fixed cost, or F, because it doesn't depend on the quantity. Right? This 60 doesn't change with the output quantity. Now, there's a coefficient on the quantity Q here. This one can be viewed as the marginal cost per unit. It's basically, it costs you $4 to produce each additional unit, right? So it's Q plus 1, you got additional 4 into the total cost. The average variable cost is the variable cost divided by quantity, and it is what? You can view 4 times Q as the variable cost because it is changing with the output quantity. Right? It is the total cost portion that changes with the output quantity. So 4 times Q is the variable cost, and then the average variable cost AVC is 4Q divided by Q, give you 4. So here, in this particular total cost function, right, you have the marginal cost equal to the average variable cost. Both are 4. They're the same 4, but again, the marginal cost is a different concept than the average variable cost. It's just in this particular functional form, the marginal cost equal to the average variable cost. Okay, let's look at some calculation example. Let's say the quantity of output is 5. Then the total cost is 60 plus 4, this 4 here, times 5. 4 times 4 is 20. 20 plus 60 is 80. Now, think about average cost. Total cost divided by the quantity. 80 divided by 5, you have 16. So 16 is the average cost or average total cost when you produce 5 units. What is the average variable cost here? It's 4. We have done the calculation. You can say, it's 20 divided by 5, right? It's 4. What is the average fixed cost? It's 60 divided by 5, right? It's the fixed cost 60 divided by the quantity 5. You have 12. Again, if you want to see the total cost, total average cost, it will be 12 plus 4, the average fixed cost plus average variable cost. You have 16, right? 12 plus 4 is 16. Now look at the next unit, right? Let's say now we produce another unit. You have total quantity of output 6. The total cost is 60 plus 4 times 6. 4 times 6 is 24. 24 plus 60, you have 84. The average cost for 6 unit is 84 divided by 6. You got 14, right? So again, 84 divided by 6, you got 14. And then average variable cost, again, is 4. You can say it's 24 divided by 6, or just use our conclusion before, that's the 4. Average fixed cost now is smaller because it's the same 60, right? 60, when you're producing 5 units, it's 60 divided by 5. Now you're producing 6 units, so it's 60 divided by 6, you got 10. Okay? So now when you're producing more, the average fixed cost is lower. So this is some simple calculation. And then on this picture, right? I have mentioned the idea before, right? If I give you the average variable cost and average cost, you figure out, there is the difference between the two is the average fixed cost. And if the average total cost is 27.2 and the average variable cost is 21.2, the distance between the two is 6, right? So here, when you're producing 10 units, the average fixed cost is 6. So now we know what? We know the fixed cost itself is average fixed cost times the quantity. 6 times 10 got 60, right? So that's a way to figure out exactly what is the fixed cost. And then, based on the quantity and the average costs, right, you can figure out what is the total cost of producing 10 units. What do we have here? We have the average cost is 27.2 times 10, you got 272. That is the total cost to produce 10 units. And the total variable cost, or say just variable cost, is what? 10 times 21.2, you have 212. That's the variable cost here. Okay, that's the variable cost. The average variable cost is 21.2. And because you're producing 10 units, 21.2 times 10 is 212. So after talk about the short run average costs, we are moving to the long run average cost. And again, the focus here is still the average cost curve because it gives you the quick idea about per unit profit or loss comparing the average cost to the price you can receive per unit. Here, when you move from short run to long run, the key difference is that you can actually change your capital input, right? That's the concept for the difference between short run and long run. In the short run, you cannot build more factory or make your factory larger, but in the long run, you can completely build a new factory or even destroy some of the factories you already have. Okay, that is changing capital input. Okay, as long as the time period allow you to change the capital input, then you're in the long run. Okay, it doesn't matter whether it's a month or it's a year or it's 10 years, right? The time period that allow you to change the capital input is the long run. So that's the key difference. Now, when you're in the long run, it means, right, you can choose the size of your operations. Here in this particular picture, we're talking about, building more and more factories. You can also think about, just make your operation larger and larger. What can happen is basically all these larger operations or the more factories, they can share some common costs. And so there's a chance to get so-called economies of scale, right? You have a larger operation, the average cost is lower. But what we care about in this picture is this story, right? If you change your factory size, let's say give you 5, right? give you 5 factories, and you can choose between using 1 factory or using 2 factories or 5 factories or 4 factories. That's your choice, right? And then the so-called long-run average cost curve is this so-called envelope, right? The lowest portion you can go between different number of factories choices, right? If I have 1 factory, this is my lowest possible average cost, right? Now, if I have another factory, right, and to produce, let's say this quantity here, right, I can use 1 factory or 2 factory. And turns out if I use the second factory a little bit, it means I can lower my average cost even further, right? And then if I produce beyond this quantity level, right, then I can achieve lower average cost by using not only 2 factory, but the third factory as well. So this so-called envelope curve, right, kind of covering the lowest portion of every short-run average cost, give us the long-run average cost. It's the long-run average cost. Okay. If you have many different choice of operation available to you, right? The long-run average cost kind of looks like this, kind of a smooth curve, kind of the extreme case for limited choices of operation scale, right? Here the operation scale is unlimited, so you kind of get a smooth curve for the long-run average cost. Now in your textbook, right, we have 3 different operation scale size. This is one, and this is another one, right? Another one. The second one, short-run average cost. The third, short-run average cost. So if you only have these 3, what we will have is this long-run average cost, the light green one that enveloping the kind of covering the 3 short-run average cost curves, right? And when you have a large number of different scales, right, you have this darker green envelope line for the long-run average cost. As our textbook noted, there are different shapes for the long-run average cost curve. It can be downward sloping, it can be flat, or upward sloping. And here in this table, we have the all 3 situations, right? You can have the quantity increase from 1 unit to 3 unit. The long-run average cost can decrease, and that is so-called increasing return to scale or economies of scale. Right? You increase your operation and the average cost decrease. If you further increase the operation from 3 units to 6 units, you can imagine it's 300,000 units or 600,000 units, and very large numbers. A small number will do the same service for us. Right? But here, the long-run average cost doesn't change. It's so-called constant return to scale. And if you increase the operation further, right, the long-run average cost increase. It's actually a so-called decreasing returns to scale, or it's the diseconomies of scale. Right? So when the long-run average costs start to slope upwards, it's the diseconomy of scale. And in the downward sloping portion is the economies of scale. This is another important concept to remember. And a related idea is this average cost, short-run average cost curve. It also has this U shape, right? the upper slope comes from the increasing marginal cost. This U shape is caused by the diminishing marginal product. Right? You put more labor into your production process with capital input fixed, the marginal output is diminishing. So that's the diminishing marginal return for the short run cost curve shapes. And for the long run average cost curve shape, you have the economies of scale or diseconomies of scale. Finally, let's talk a little bit about learning by doing. What this says is that if you increase your operation scale, right, you first enjoy this economies of scale, right? You produce more, the average cost may decrease. But at the same time, right, this curve does not catch the idea of learning. This is no learning by doing, right? But if you have learning by doing in the process, that means you produce more, right? The workers, the managers, the technicians become more knowledgeable, more skillful with the production process. They can drive down the long run average cost even further. So without learning, right, you only have economies of scale. If you produce quantity Q1 to Q2 to Q3, right, the average cost only decrease from A to point capital B to point capital C. But with learning, right, the average cost curve also shifted down. Right? This is learning by doing. So the actual average long run cost changed from point A to point lowercase b to point lowercase c, right? As the operational scale increase, as you produce more output, the long run average cost can be even lower than provided by simply the economies of scale. That's learning by doing.